Are you able to hear me? Please use the chat window to respond to our questions. Great. Thanks for the confirmation. So welcome to our introductory webinar on Big Data and Hadoop. My name is Anjana. I'm part of the team here at No Big Data. I'll be taking you through what to expect of this session. So just make use of this time to send in a one-liner introducing yourselves, where you're from, what you do, where you work, whatever you would like to share with everyone here. All right. So this is going to be a 3-hour session. The first half is going to be on understanding big data. Then there'll be a 10-minute break, and we'll be moving on to Hadoop architecture. The session is being recorded, so you can sit back and relax. You don't have to make notes. We'll be sharing the recording and the presentation with everyone present here. So at No Big Data, we really encourage questioning. So please send in whatever questions you have through the chat window. Since this is a session that is open to many people, this is a demo session, so everyone except the instructor is going to be muted. The instructor will read out the question before answering it, so for better answers, it'd be really great if you could avoid chat language and send in clear questions, short, clear-cut questions, please. So this is session 1 out of our 11-session Big Data and Hadoop course, but on its own, it will suffice as an introduction to big data technologies. So let's move on to getting to know big data before the session starts. So we have expert instructors, something that we take pride in. They are industry experts. You'll soon find out how true that is during this session with the instructor we have today. As part of the course, we provide access to Cloud Labs, which is a cluster that you can use to experiment with whatever you learn during the classes. This feature is unique to No Big Data, and it gives you a real-world feel. Course takers are also given lifetime access to our learning management system, which will include all the presentations, recordings, assignments, and project work. It's lifetime access, so you will be able to always come back and refer to any of these. At the end of the course, you will get a real-life project to complete and will receive a social media compatible certificate. You can put it up on LinkedIn, Facebook. You will also have 24/7 online support. Even after you finish the course, if you have any queries, anything, you can always write into us and we will be responding to them. You'll be part of our alumni group, which will keep you posted of new job opportunities, help you stay updated and connected. So let us move on to the session today. Our instructor is Sandeep Giri. I'll let him introduce himself and take it over from here. Have a great session.
Hello everyone. Great. Is everyone able to hear me clearly? Is my voice clear to everyone? Great. Great. All right. So we have Akash in the session, and Akash has got 10 years of experience in IT industry and is working on the Microsoft technology stack and is interested in learning big data. Great to know you, Akash. We have Shekhar Singh. Shekhar is still an student. All right. So feel free to give me a one-liner about you. it is important to know you. Okay. So, welcome, Sekhar. You have taken a very good decision to attend this session, and this will be a good experience for you. Even if you are a newbie into big data domain or into data technologies domain, you will like this session definitely. All right, we have Vijay. Vijay is having 10 years of experience looking to learn big data. So great to have Vijay and Akash who are having 10 plus years of experience in IT industry. Great. And we have Darshan. Darshan is having 6 years of experience in Selenium. All right, great to know you, Darshan. He is into testing technologies. And we have Vijay. Vijay is from Microsoft Stack. Great. And so Vijay's profile and Akash's profile are quite similar to each other. Brilliant. And okay, so Darshan has 1 years of experience in Hadoop administration. Great to have you in the session, Darshan. You will definitely find still, even if you have a Hadoop administration training earlier, you will still find it useful. So feel free to introduce yourself so that I am aware of who am I talking to. All right, so we have a great set of experience as well as fresh out of college in this session. This session is going to be fairly informative as well as introductory as well. So we have Sridhar. Sridhar has 15 years of experience in IT, specifically in service delivery and project management. I would like to learn big data and Hadoop. Brilliant. Great to have you in the session, Sridhar. You will definitely find it useful. Brilliant. So, a little bit about me. I did my graduation from IIT Roorkee in 2002. Afterwards, I joined a company called DE Shaw. Only few of you might be knowing DE Shaw. It's a company where we dealt in big data even before we used to call it big data. Okay. We had a 10,000 node cluster in 2002 when everybody else was not actually setting up that kind of technology stack. And that time we were having systems where we used to churn humongous amount of data, the data that was difficult to transfer over the wire. So we used to get the data through the courier. Okay, so now you can imagine how big data we are talking about. Okay. Next, I founded a company called Tbits Global. Tbits Global is in document management systems, and it was an enterprise class document management system capable of handling huge data sets. Afterwards, I joined InMobi and then Amazon. At InMobi and Amazon, I worked on mostly the big data kind of project. At Amazon, I built a product for stream processing, similar to what you have Hadoop Spark streaming, or you can say Storm. And at InMobi, I built a recommender that where we churned around 200 terabyte of data to give the recommendation. So that's a bit about myself. And last year we started No Big Data. Okay, with a clear vision to fill the gap in learning industry and to do innovation in learning industry. And we are very happy to tell you that we have been able to do a considerable amount of innovation in the big data learning industry. As of today, we have built something called Cloud Labs, which helps our student learn in real life. Okay, learn on real life running Hadoop cluster, and that is something which we have built for keeping our students in mind. Okay, so that user does not have to haggle with the virtual machine or other kind of issues, and we give the CloudX lab for free to all our students. Okay, so we are very proud of our innovation called CloudX lab. We are providing CloudX lab to other competitors of no big data, and the term cloud labs is something which we started with. As of today, some of the competitors of no big data take the cloud labs from us only. Okay. All right, so that is these are few of our unique proposition. And about myself, today we will go through big data introduction, and you will see the in first half we will talk about what is big data and why it is so hubbub around big data technologies. In second half we will talk about Hadoop and the ecosystem. All right, if you are aware of these components, these parts already, then you then it is up to you whether you want to continue or you want to I mean leave. Okay, so all right, so the whole session is around discussion, it's not a one way. All right, so keep on asking questions since there are many attendees in this class. So so please type the question because everybody else is muted. So keep on asking questions. So let's start with a simple icebreaker. What exactly is big data? What is your understanding of big data? Let me ask you this. So feel free to answer it using the questions window. All right. Akash, Sridhar, Ram, Amit, Yogesh, Vijay, Madhusudan, Shekhar, Rahul, Sudhindra, Darshan, Nilesh, Amit, Mike, Richard, Seema, Sabaj, Karthik, Kanusha, Alok. All right. So what do you understand by big data? Yes, Steve. So Darshan says it's large amount of data, structured, unstructured, semi-structured, which cannot be processed with traditional tools. Okay, okay, that's a Darshan's answer. Good. Nilesh is saying big data means huge data. Sridhar says it's a collection of huge data. Sudhindra says large volume of structured data. Good. Sabha says big data is large amount of the data that is captured but can't be analyzed. Big data is something that we can collect and derive a outcome in short analysis. Raj says large amount of data. Vijay says large complex data. Brilliant. Great set of answers. All right. So let me summarize it. Okay. So all throughout the session, we will stick to this definition of big data that has been accepted by Hadoop and all other ecosystem people. And the definition is a data of very big size that cannot be processed using usual tools. When we say usual tools, it means your normal file systems or normal databases. Okay. Third is to process such kind of data when the normal tools are useless, the only way to go forward is a distributed architecture. What does it mean? It means executing something on multiple computers simultaneously. That is distributed architecture. Now, the data could be of any format. Data could be structured or unstructured. All right. So, the most important part out of it is when the data grows to such a big size that we cannot handle it using normal tools, because most of the usual tools used to work on a single computer, and for handling such kind of data, whether we are storing such kind of data or we are handling fast stream coming with this kind of size, then to handle this kind of data, we have to go with distributed architecture. And what does it mean by distributed architecture? Getting something done using multiple computers. All right. All right. There are two more questions. Madhusudan says big data is four V's: volume, velocity, variety, and variance. Okay, Madhusudan, good point. So the fourth V is that fourth V is uh, not variance. It's what do you call veracity. Okay, we will talk about it later. Now, Ram's question is point is today's big data is tomorrow's small data. Today's tool will not be able to handle tomorrow's big data. That's correct. Very much correct. Good point. Thank you, Ram. All right. Let's keep on moving. Great. Now, when we talk about data variety, when we say structured, unstructured data, what does it mean? It means, let's have a look at this chart. So, when we say structured data, it means in the data we know clearly what are the fields, as well as we know clearly what is the data type of fields. Okay, what is the data type of field? For example, in a database we clearly know what is the data type of each column and each column and we clearly know that what are the total number of fields in the input. So structured data can be thought of as like a database table, or the other example of structured data would be JSON objects. In JSON object, we clearly know what are the various fields in the input. Also, we clearly know what is the data type of every value, right? Whenever we are inserting something into our MySQL, my MS SQL or Oracle, we clearly define that it has got to be a table, and this table has got these many columns, and each column has got this data type, right? That is structured data. Semi-structured data is when we know the fields, but we do not know their data types. Okay, so we know half of the structure. For example, a CSV file is a semi-structured data. Unstructured data, we neither know what are the input fields nor we know the data type of those fields. To find out, to convert unstructured into structured, we have to parse the input data. All right. So this is the definition of structured and unstructured. Next is the distributed computing. What does it mean by when I talked about big data definition, we said that to solve our big data problems, we require distributed computing. It means group it's a group of networked computers, or you can say networked computers which interact with each other to achieve a common goal. All right. So we take the computers, connect them to network or to normal Ethernet or whatever mode you want, and then we assign them parts of the problem and let them solve and get the results consolidated. That is what is known as distributed computing. Sometimes we also refer distributed computing as parallel computing, but the definition, there is a minor definition difference, but that's something out of context right now. All right. Raj is saying that please repeat the semi-structured data. Semi-structured data is Semi-structured data is the data in which we do not know how many fields are there, but we know, sorry, semi-structured data is the one where we clearly know how many fields are there, but we do not know their data types. Let's take a case of CSV file. What is CSV file? It's a format where we store each row in comma separated format in plain text file, right? You can edit a CSV file in an editor and you will see that each row contains values which are comma separated. Okay, so based on comma, we can identify that these are the fields in our CSV file, but we cannot identify whether a field is a integer, or a field is float, or a field is string, or a field is date, right? Meaning we do not know the data type, but we know how many fields are there. That is semi-structured. Any example of unstructured data? Definitely. So let's take a case of the logs that we gather when we are dealing with any application. So the way applications store the log is in plain text file. They keep on saving it line by line, right? So Apache logs is an example of unstructured data. We do not generally know the unstructured so easily. To convert unstructured into structured, we have to understand the data and also understand how to process and parse it. Make sense to you, Akash? Great. Now, when we talk about distributed computing, one part of the distributed computing is we distribute the work to multiple computers, right? And when we say we distribute work, which means work is our code, okay? And we distribute the code as well as data to multiple machine. And as part of distributed computing, we ensure that we take code to the data instead of carrying the data to the code. For example, in this here we are taking the code, as in here you can say we are taking our operator, which is our tool, right? You can see X, we have taken to the tree. In the second picture, we brought the wood to the tool, right? This is not something which we prefer when we deal with big data. We always try to move the code instead of data. Reason being, the data is generally huge in size, and therefore it doesn't make sense to carry it. All right. All right. Now moving to the classic definition of big data. The classic definition of big data is, other than our definition, although we are going to stick with this definition, that anything when we want to process, we require distributed computing, is a big data. All right. These are the reasons why something could become big data, why a data could become a big data problem, right? So these are the three reasons or three characteristic of big data that make it big data. One is volume. You are gathering terabytes of data, and after a point of time you do not know how to store hundreds of terabytes of data because existing systems cannot handle storage. Okay, so that is volume. So volume characteristic can make the data big data because you could not handle it using one machine, so you needed multiple machines for the storage. Okay, so the problems related to the storage of huge data reliably. Okay, for example, your website is gathering lots and lots of traffic per day, and the logs that are generated, what is a log? Every time somebody hits your website, you make an entry into a file, and that is called log. Okay, whenever your application is running, it keeps on writing to files informing the debug activity, information activity, error activity, or some fatal or critical activity. So all of this information which is being continuously saved into disk is called logs. All right. Now, storage of log could be a big data problem after a point of time if your website is having a huge traffic. Second is, so that was volume, the data at rest. You are not dealing with real time traffic. Now the second characteristic of data that could make it a big data is velocity, data in motion. Imagine Facebook. Facebook gets requests from billions of users every minute. Like your phone, your laptop, and everybody is hitting the Facebook server every minute, every second. to get the data. So total number of requests that are reaching concurrently to concurrently meaning at the same time at Facebook server are too huge to be handled by a one machine. So when you grow into so many requests per second, your one single machine cannot handle that. For handling that, you need different kind of databases, you need different kind of load balancers, and you need different kind of storage. So basically the velocity of 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 your data could make it a big data. For example, if in this session there are 700 people, in this session there are 700 people, imagine that by the end of it I must have transferred 700 gigabyte of data to 700 different people. Okay, if the total video size, the audio video size is 1 gigabyte, I would have transferred 700 gigabyte of data parallelly to 700 people. So this number of requests that are going out, the video, the pace at which the video is moving out is a problem of velocity. Or you are having a website tracker which people keep on putting in their own websites to track number of visitors on their website. So the number of requests that you will receive will be the sum of all your customers who are putting this your script in their websites. Okay, every time a visitor visits somebody's website, a, a request is coming to you. Okay, so in such case you will soon run into a problem of velocity because there will be too many requests coming to you. So velocity is another reason why you revert back to big data solutions, meaning distributed computing solutions, meaning you need multiple servers running parallelly to handle such kind of loads, maybe thousands of servers in case of Facebook. Third is variety. Variety means data in many forms. Okay, so now when we say variety, variety could be looked at in two ways. First, data in many forms. Second, problems of many forms. Okay, although they look like two different things, the problems, variety of problems and variety of data, but they are actually the same thing. Okay, if if your data is not in the format in which your problem demands, then you have to translate it, you have to solve the problem. Okay, so for example, if your data is a graph, and in this graph you have to find path from one place to another, that's a variety of data. Okay, that's a variety of problem or variety of data, it's the same thing. All right, or you are given a big social graph, as in if you compute the total number of people who are connected to you and who are connected to them, and so on, there will be millions of users even in the third degree. Okay, there will be millions of users in 3 degree from you, right? So if you try to do any kind of analysis in this kind of complex structure of data, then you will soon run out of resources, and therefore you would require a distributed computing architecture to solve such kind of complex problems. All right, so was I able to explain to you the what is the meaning of volume, velocity and variety? Yes, Raj and Pooja, you have questions for me? Sridhar is saying, can you please repeat the variety? All right. So variety means data in many forms. So sometimes, even though your data volume is low and the velocity is also low, but the kind of problem are you trying to solve, the kind of data you are trying to churn might be very complex. And that could lead to big data problem, meaning you would require distributed architecture or multiple computers to solve your problem. Okay, let's take a case of Google Maps. Google Maps is a complex data structure. It's a graph of so many streets and so many circles, so many connecting points, right? If you have to find a direction from one city in one state to another city in another state, and that too for bicycle, think about how many nodes it has to go through. How many possible ways from one point to another point in the graph would there be? And to solve such kind of problem, either you have really huge computer, which is hypothetical in this sense, or you will have to use multitude of computers parallelly to compare the approaches or to find the approaches from one point to another. Okay, so these are very important criterias for finding the. So so when you have such kind of big data, there are, when you have such kind of complex data structure, you will have to have a distributed computing infrastructure to solve it in time. Okay, so did I make a sense, Sridhar? Was I able to answer your question? Great. Any other questions at this point? Keep asking the question. Do not wait for me to finish. Okay? I will manage it by myself. I'll answer the question at the end of slide. No worries. But you keep on asking the question as and when it strikes you. All right? Otherwise, the whole session might black out for you. All right. All right. Here is another question for all of you. How many petabytes of data are there? How many bytes are there in a petabyte? Yes, everyone? Okay, great. Yes, Sridhar and Raj, you have raised your hand. You have a question. You can ask in the window itself. Great. All right. So so Shabaz, Madhusudhan, and Sridhar and Ram all have the same answer, that it's 1024 terabyte of data. Okay. But I asked for bytes, not terabytes. All right. Nilesh is saying it's 100 terabyte. Are you sure, Nilesh? Yes, Sridhar, you have raised your hand. You can type if you have a question. Okay, okay. Sekhar is saying 1024 to the power 5. Interesting, interesting. Great, great. So you all are right. Great. All right, all right. So it's around 10 to the power 15, meaning having 15 zeros. Brilliant. Now, the way you can remember it is kilo, mega, giga, tera, peta, exa, zeta, iota. And 1 byte means 8 bit, meaning it can store around 256 states. Each byte can store around 256 numbers or 256 states. All right. Now, so we talked about two things just now. We talked about two things, that how much in 1 petabyte, how much is 1 petabyte. We told that okay, it's 10 to the power 15. And we also talked about what is big data. Big data is something which, big data is a data that can be churned or that can be handled by distributed computing. Now, question to all of you is 1 petabyte a big data? Is 1 petabyte big data? Everyone? Yes, see there? Okay, let me simplify it. Does one, if you have to count just the vowels in 1 petabyte data and data every day, can you do it on a single machine? All right, great, great. So, yeah, almost all of you are agreeing that we cannot handle it without multiple machines. It is not possible. Sekar's point is no, we can't do it as we need distributed computing to process such data. And Akash says no, it requires distributed computing, distributed system. Great, great. Sridhar says difficult task. Ram says not sure. Okay. And Ram also says no longer. All right. All right. Great. So yeah, so Ram, when we talk about that's why your point earlier was that big data for today might become the small data for tomorrow. Okay, because the definition of usual tools, definition of traditional tool might change. Therefore, we have kept ourselves to a very objective definition, that is, does it require multiple computers or not? Okay, great. Now, as opposed to our common sense that for processing we require CPU, in this problem, when we say we are just counting vowels in 1 petabyte data, meaning we will go on to this data, we'll go through this data one by one from left to right, right? So here, processing is not that much required. All we need to do is keep reading data and just keep checking every bytes. Okay. Now, the main thing that becomes bottleneck in such case is the IOs, the rate at which you can read the data from your disk. Okay. So is 1 petabyte big data? Yes. Most of the existing systems cannot handle it. Most of you are correct when you said yes. All right. Now let me try to answer why is 1 petabyte data big data by asking another question. Okay. So here is the question for all of you. How much time does it take to read 1 terabyte from a hard disk? Hard disk is the disk which you generally have in your computer for permanent storage. Permanent storage as in between the power cycles, between you shut down and start, the hard disk stays, the data in hard disk stays unless it gets corrupted. So question is, How much time would it take for your computer to read 1 terabyte of data from a normal hard disk? Anybody can just give me an approximate number, even if you are wrong by 100%. 100% as in, if your answer is double or half, is completely okay. Sridhar says few hours. Anybody else? Okay, brilliant, good answer. Sridhar says few hours, Nilesh says 1 hour, Akash says 1 to 2 hours, Mohit says more than 12 hours, Sridhar says 7 hours. Brilliant, brilliant. And Ram says 12 hours. Sabah says few days. Vijay says 1 hour. All right, here is the answer. So it will take around 6 hours. So uh, who was most close? Sridhar was the closest to the answer. Yes, Raj says depending on fetching speed of computer. So you can assume that the disk is 5400 RPMs, rotation per minute. Sekhar says it will depend on buffer size and processor's clock. Are you sure in that? So whenever we are dealing with the disk and we are just reading the data, buffer size hardly matters. What matters is at what rate your hard disk is spinning. Buffer size matters when you are dealing with the faster drives such as RAM, such as SSD. Okay? Yep. Madhusudan says it depends on disk IOs. That's correct. But we are assuming here average disk IOs. And also the fastest disk and slowest disk is hardly I mean hardly 50% difference. All right. So yes. So when now you can think of it, when it takes 1 terabyte data to be read, when it takes 6 hours to read 1 terabyte data, for reading 1 petabyte data it will take 6,000 hours. Okay, 6,000 hours is what it takes to read 1 petabyte of data. Okay, so you can think of it, and it will take around 30 days to read 1 petabyte data if it is stored on a big disk. Now you can see that even though, even if we have fastest processor in the world and we have the biggest RAM in the world, the disk will still take close to 6 hours to read 1 terabyte data. Okay, and this is one of the biggest cause of making big data impossible to be handled by a single machine. Okay, this is the biggest constraint when we deal with big data. It's the IO, it's the disk IO which becomes the bottleneck. Okay, although we'll talk about more bottlenecks after this. So why big data? Because data storage has grown exponentially after 2002, which is known as digital age. This graph shows two parts: analog storage, as in the data which is stored in traditional means, as in paper and other means like videotapes and cassettes. That's analog storage. Digital storage is something like hard disk, USB, and other. Okay. So in 2002, because there were many reasons why after 2002, data became so far, data accumulation became so high. Okay, why it's important now, or why after 2002 the data increased exponentially. Okay, why? The two big reasons: one, smartphones or devices, smart devices, or, and second is connectivity. Connectivity between things, connectivity between people. Okay, so on one hand devices became cheaper, faster, and smaller. The connectivity kept on improving. As of today, you have Wi-Fi's everywhere, you have 3Gs, you have 4Gs, and you have all kind of networks. All right. So on one hand, devices became cheaper, faster, and smaller, meaning people were gathering more and more data because of devices. People are taking photos, people are, when they're making call, their call records are being done, when they are generating documents from the phone, when they are sending messages, receiving messages, sending emails, all of that is happening on the phone. Okay, and when you are connected, to internet, suddenly your data generation becomes really high. For example, in case of messages or sending messages, it only makes sense if you are connected to other people. Okay, and therefore although the data is being generated by the phone, like you're typing on the phone and generating a message, but the data is getting multiplied because of connectivity. The connectivity between people, connectivity between things, is what is causing such a huge uplift in the data generation. Make sense to you? Although this is common sense, but we need to understand this part. All right. A quick question to all of you. Which components impact the speed of computing? CPU, memory, IO speed, as in memory read and write speed, disk size, and network speed. Saba says processor, memory. Okay. Nilesh says, Akash says E. Nilesh says G. Sudhin says G. Kanushka says CPU. Alright. Vijay says G. Saba says network speed for distributed ones. Okay. Processor, memory, and network speed. That's what Saba just said. Vinod says memory read speed. Alright. Alright. So Madhumita, Vijay, Akash, Pooja, Yogesh, Vinod, and Ram all say all of the above. Now, question from Ram is all except disk size. Do you agree? He says that all from A to F except for E. All right. Let me answer him. All right. Actually, the answer is G. All of the above. Okay. And I'll explain to you why is it so. All right. The reason is, okay, I'll explain to the answer of explain to all of you the answer of this question in this. All right. So when we talk about computing, it's not only about processor, though processor is the most important component, but processor is not the bottleneck. Or you can say processor is bottleneck only in very few cases. All right. So when we talk about computing, there are four pillars to it. There are four pillars of computing, or four components that matter most. One is CPU. Okay, the ability of a computer to read the instruction and take a call, whether test a condition, whether to go to step number next or some other step. Okay, the ability to switch and ability to communicate to all other devices is what is the job of CPU. So now you can automatically think about it, that if the pace at which CPU is deciding whether to go left or right, if that is slow, then definitely your processing is slow. But mostly CPU is fast enough. When we talk about fast enough, we are talking about even in the normal computer as of today, on an average, the processor has got a speed of of around 2 gigahertz or 5 gigahertz, meaning in a second it can it can take about 10 to the power 9 decisions of checking a condition where to go left or right. Okay, so now you can, when you think about it, CPU is actually fast enough. CPU is actually fast enough. Now second problem is the RAM. Second component that matters is RAM. And what is a RAM? RAM is a component in the computer from which the CPU reads and writes to. All the instructions are loaded into the RAM, and then the computer keeps on reading and writing to RAM as well. Now you can think of it, when the processor is continuously using RAM for almost every operation. So the faster the RAM is, the faster the CPU would be. And mostly CPU is blocked in computing by the RAM, because RAM's speed are slower than processor's ability to read and write. Okay, therefore faster the RAM is, better it is. Now why does size matter? In case RAM is of smaller size, the data will be kept in the disk, because if the data is not fitting into the RAM, you will have no choice but to write to the disk. And whenever you do that, there is an overhead. Whenever you require that extra piece of data, you will have to again go to the disk, read it. Now third part, which is another important part, is disk speed. Now disk speed is at what speed you read the data. And trust me, in case of the problems when we talk about the volume, the three V's we talked about, in case of volume, it is the disk read speed which become the bottleneck. Okay, as we also talked in the previous slide, that it takes around 6 hours to read 1 terabyte data. So disk speed is the most important component when we deal with large volume of data. But when we deal with large velocities of data, it is the RAM which becomes the bottleneck, and it is the network which becomes the bottleneck in case of large number of requests per second you receive. Okay, so other than disk speed, disk size is also very important criteria, because if the disk size is small, then you will have to put your data to the network. And if the data is a network, then the network is generally slower than the disk speed. Therefore, you will further your speed, the computing speed will get further slowed down. All right, now when the data keeps on growing, you end up storing data in another computers, meaning in the network, and therefore automatically the focus shifts to the network when we deal with big data. Therefore network speed matters a lot when we talk about computing, when we talk about distributed computing. All right, was I able to answer your point, Ram? Do I make sense when I talk about these four big constraints or six big constraints? Great. All right. So when we deal with big data, at least one component of these become the bottleneck. All right. Any questions at this point before we move forward? It's very important to understand that other than CPU, there are other components which become the bottleneck. CPU is the last thing that becomes bottleneck when you do the computing. Only in the case of variety, the last one out of V, when you have to do the computing of complex graph, complex map, or where the lot of conditions need to be checked, only in those cases the CPU becomes the problem. Great, great. All right. Now we talked about what is big data, causes big data, and we also talked about why big data handling is a problem. All right. Now the question is, what's the point? What is the benefit we can derive out of big data? All right. So when all right, let me have a look at somebody has raised. Yes, Sridhar, you have raised your hand. You have a question for me. All right, great. All right, it was just a mistake. No problems. Yes. So what's the point? What is the benefit we are thinking about when we say big data? Okay, there are hundreds of problems in the world, but why are we talking about big data? Can it help us in any way? Okay, in short answer, in very simple answer, there are some problems where handling big data is unavoidable, such as handling such a traffic in case of Facebook. So they have to inevitably solve handling big data no matter how. Or e-commerce companies. Now, second class of problem is the analytics. Okay, that's a nice to have and a greatest thing to have. Okay, and when you have big data, the analytics is better. All right, because the average of too many numbers is always better than average of few numbers. So law of large numbers very much applies on big data. So there are many example use cases which are already in production, and there are really brilliant solutions people have built, starting with e-commerce companies such as recommendation system, recommendation engine. We will take care of recommendation engine in the next slide. All right. So keep asking question. If you have any question, feel free to ask. No question is bad question. Okay. So if you have a question in mind, please ask, because somebody else might be having the same question and may not be asking the same. All right. Good. Great. And let's go ahead. Do not wait for me to finish the slide to ask the question. All right. So when we talk about web and e-commerce companies, the recommendation engine is one. Second is search quality. Observing what are people clicking upon would make search engines like Google search engine understand which search results are better. Second, if you have to give autocomplete kind of tool or autocorrect kind of tool or spelling mistake suggestion kind of tool, you will have to crawl a lot of internet to build such kind of dictionary which can give immediate suggestions, and that requires a huge analysis of data. Third is sentiment analysis. So what does it mean by sentiment analysis? We will cover it. We will cover it in a minute. Okay. And A/B testing is another use case. Now, what does it mean by A/B testing? A/B testing means testing whether a new improvement or new innovation is actually helping users or not. A is the existing control, and B is the new changes. So we are testing the behavior of end users towards a new product or new feature. Okay, so the way we do it, the way we used to do it at Amazon is we continuously build features. Okay, we continuously build lots of features and lots of improvements, but before putting it to all the users, we used to give it only to 1% random users and then see whether they are able to make the purchase or not. If they are not making the purchase, or their time for which they stay on a page is reducing drastically, then we would take down the new changes which we have done and revert back to the original. But if our user retention time, the time for which our users are seeing a page, that 1% small selection of the users, if they are seeing, they're staying on the page for some more time, then what we do is we keep an increasing number of users for this new change. Okay, so A/B testing is like drug testing. Okay, you have a lot of users. For some users you give just the water, as in, but you don't tell them whether they are given water or they are given the drug. For some of the percentage of users you give the drug. Okay, and then you compare who got treated and who did not get treated, and that is how you generally test a new medicine. In the same way, these e-commerce companies and search engines, or probably most of the B2C companies, build their A by B testing. We call that A/B testing. Meaning, let's say you came up with the idea that if you change the color theme to black, suddenly the sales will increase, right? So instead of changing it for all the users, you do it only for 0.1% of the users or 0.01% of the users and observe their behavior. Are they buying more or are they buying less? If they are buying more, that means your that means your changes have worked, and therefore let's put it into all, for all the users. Okay, now why does it matter in case of big data? Why does A/B testing matter in case of big data? The reason is, if you have big data, only then it makes sense to do the A/B testing. If you are only getting, say, 10,000 requests per day, it doesn't make much sense to observe a small percentage of users. The data might be very misleading. Okay, the data might be very misleading in case of small number of users. Therefore, big data is very useful in case of A/B testing. The bigger the data, the better will your insights get. All right. Now, next is the telecommunications. In telecommunications, if you think about it, there are billions of users concurrently using their service. Not billions, at least millions of users concurrently using the service. Now, now, obviously, the data at the telecom side, the telecommunication companies, is big data. I've talked to at least 5 6 telecommunication companies who are actually working and are already using big data to solve their problem of storage, their problem of velocity, and their problem of complex analysis of the data. Okay, such as customer churn prevention. They use big data to figure out, they use the data of customers to figure out why did a customer leave, and that can be done in variety of ways. For example, observing for how long, how was the connectivity for a particular user, how many calls did he make to the customer service support, and how, and also what was, how many message, how many, what was his usage of the service. So based on all of this, you can always figure out why did a customer leave you. Okay, now next is the network performance optimization. You could do, if you know the numbers, if you know the user distribution, you can do the network performance optimization. Third is call data record analysis. Okay, if you have to analyze, they have to, telecoms have to analyze the call records for various kinds of security reasons. They can do it, but they would require a distributed computing, or they would require a big data solution. Fourth is analyzing network to predict failures. Okay, so it is actually possible to predict failures based on the past history. Okay, if you build a great set of information saying why would, why did my system fail last time. Okay, what were the various signals at the point when our network was failing, and you, if the data is big enough, you can always predict that these are the same omen, because at the same time last time the network failed. And all of this can be very well automated by using artificial intelligence. You just feed that this was the status of the system when it failed, this was the state of the system when it did not fail, and so on. If you feed enough data, the artificial intelligence algorithms, machine learning algorithms will tell you that the, given this data, whether it is about to fail or not. Okay, so Vijay's question is, what is A/B testing? So was I able to answer, Vijay, or should I repeat? Kanushka's question is, sentiment analysis means we will go back to sentiment analysis again. Okay, no worries. All right, let me make some notes. I think that is a better way of dealing with questions. So one question from Sekhar is, my little question is off topic. My question is a little off topic. Can I say machine learning is similar to big data and vice versa? Not really. Not really. So you apply machine learning to big data. So machine learning is a set of algorithms or set of strategies. So machine learning is, in very simple way, given a data based on the history, predicting the future. Okay, just like humans do, based on their past experience, they take the call, they decide, they have learned from the data. Exactly same way all machine learning algorithms learn from the data. And big data is, now why do we call big data and machine learning all the time together? Reason being, machine learning was impractical. Reason being, machine learning was impractical because for machine learning, we always required so many data sets, right? Because for machine learning, you have to feed a lot of data till the point computer starts making, uh, figuring out some correlation. Therefore, machine learning works well on big data. The bigger the data, happier is the machine learning. All right, does it make sense, Shekhar? Okay. Customer churn prevention from, okay. Cu- So customer churn prevention. So that's Pooja's question. So customer churn prevention means figuring out why are customers leaving your services, and also figuring out what can we do to stop the customers leaving us. Okay, that's customer churn prevention. Great. So moving on, there are few more. I mean, there are actually lots and lots of branches of various services and products which are using big data in variety of ways. Okay, there are governments and healthcare. Government is using it for fraud detection, cybersecurity, welfare, justice system. Health and life care system, life sciences are using it for information exchange, gene sequencing, and various kinds of healthcare, along with drug safety testing. Any questions at this point of time? All right. So Raj's question is, there are many applications. His question is, there are more. Are there more applications of big data? Yes. So to keep my slides small, I have kept only the one which you can relate to. Okay. So almost every branch of science and engineering is being impacted by building the ability to handle humongous data. Almost every branch of science and technology, every branch of human work, human I mean every industry is being impacted because of big data. Okay, be it banking, be it, yeah. In banking also, other than normal transactional data, because normal transaction data is very small as compared to the other data. Okay, so in banking there are many variety of things, such as figuring out the credibility of l- somebody who is seeking out for loan, somebody who is seeking for insurance, figuring out how risky it is to give the insurance. There are many applications in big data in banking. All right, great. Any questions at this point? All right, let's talk about recommendations. So there were two things which we left. One was recommendation and other was sentiment analysis. Recommendation is probably the most important thing that happened in big data. The first thing you may also like from Amazon proved that the recommendations are the most credible ways to bring customers, to increase your sales. If you are able to give great recommendations or great suggestions of products, your sales will increase drastically. Okay, so most of the Amazon sale started happening because they started sending recommendations in the email. Okay, so recommendation could be very simple as customers who bought this particular product also bought these products. Okay, Second is you may like to wear this one. So you can see that customer who bought this kind of shirt also bought this kind of shirt, this kind of shirt, this kind of shorts, and so on. And here on the right hand side, there is different kind of recommendation. They look very much like hand curated. And the recommendation is you may like to wear this particular product with these other products. Okay, this is cross selling. The recommendation could go further into details that they take all the reviews about various movies from you, and then they recommend that you may also like this movie. All right. So there are many products. So there are many products which have been built on recommendations, and there are many more services that have been done on top of recommendations. And this is just the beginning. All right. For example, Netflix and IMDb both have great recommendation system. Next is that how difficult is it to build a recommender system as of today? It's very straightforward. If you are little bit aware about tools like Mahat, which are part of Hadoop, and we will be covering it in detail, you can straight away use them off the shelf to give the recommendation. All you have to do is give them three-column data, three-column in the form of user ID, product ID, and how much this user likes this particular product, and Mahat will automatically give you the suggestions for products for particular user ID. Okay, suggestions for products. Say for example, for Kumar, the movie ID is Apocalypse Now, and the rating is 4.0. For Giri, basically it has figured out based on the users who looks like who, and then has started giving the recommendations. So this is just one example of how you could quickly build the recommendation. You don't need to know algorithms as of today. You don't need to know how exactly the recommendation engine is working. All you need to do is understand how to format your data and give it to the tools like Mahat. Or there are many more tools in the world of recommendation which can give you these these great insights into the user recommendation. Okay, now there is a question from Darshan. The question is, can you please list out challenges for Hadoop adoption across companies ranging from startups and mid-level and biggies? We'll talk about it after some time. Okay, we'll talk about it after some time when we talk about Hadoop. Probably you'll get the answer by then. Okay, so did I make sense? Does do you understand what does it mean by recommendation at this point of time? So we talked about various kinds of recommendations, like we have customers who bought this also bought that. You can buy this along with this. Okay, that's complete the set. This is called complete the set. And next is the recommendations where you know the details about the end user also. Okay, in this, in these two kind of recommendations, you don't know anything about user. We basically user is not yet logged in. In these kind of recommendations, you know the user's past behavior, and then you are giving the user the recommendations. Okay, and how do you generate it? You use tools like Apache Mahat. We will talk about Mahat in one, but we'll give you the demo of this one, as in how can you generate the movie recommendation for using a tool like Mahat. And it doesn't only work for movie, but it can work with anything which has user and products. Okay. Next is sentiment analysis. Next is sentiment analysis. Sentiment analysis is a very important tool and is a very important strategy for any organization. Okay. So earlier, a few years back, when the social platform and when the platform like Twitter were not popular, the strategy to compute sentiment of your product. Understanding sentiment means you launched a product or you launch a new sales strategy and you want to figure out whether it's working or not working. Okay. Whether the reception is good or bad, you're launching a new movie, you want to see how is it going. Okay, so continuously you observe the behavior of people on various forums. How many people are liking your page, how many people are responding to your post with positive feedback or negative feedback, how many people are posting to Twitter, and you basically gather all of this data, parse it, clean it, and then gather the statistics of how many people are liking or disliking your product or brand. And you do it continuously over the timeline. You plot a graph of negative and positive feedback of the people parallelly, and then you plot it on on y-axis with x-axis being the timeline. Okay, this is called the sentiment analysis, understanding sentiment of the people towards your service or product. All right, this is very very useful when we deal with when we deal with a public brand. Okay, so so there are many strategies that play important role, but the common phenomena is no matter what strategy you use, there would be a requirement of distributed computing. There would be a need of many computers simultaneously processing such a feed which is coming in real time from across the globe. Okay, because there'll be a lot of data to churn in these scenarios. Therefore, you would need big data kind of solutions. All right, here are few questions. Let me try to answer those questions and then we'll move ahead. All right, there is a question from Raz. So, is big data has major role in applications or just additional support role in existing data tool? It's both. Okay, it's both. It's actually the moment the moment for a particular problem you realize that your volume, velocity, or variety is going to be complex enough that you can't use existing tool. I'll give you an example. For example, there is an analytics you were running very happily using R. Okay, after some time your data starts growing and it grows to an extent that it cannot fit in the computer's memory, and that point of time your R program is fairly useless. Okay, so that's a variety. So basically it depends upon this data size, and based on the data size it does play major role in almost everything, whether it's an application or in supporting role. Was I able to? Okay, so I think there's a continuation to it. After talking to customer care on mobile, company wants to know the experience. All right, I did not understand your question. Yes. So this is not a really a great sentiment analysis example. So earlier days, we what we used to do is we used to ask people. We used to give them forms and we'll ask people for their feedback. But in today's time, people have realized that asking people for their feedback has got its own problems. The data you will gather is very small and you will end up making mistake. Instead of that, you observe the public channels. Right? Good, good. This was regarding the. Okay, now. All right. There's a question from Sridhar. Very good questions. Thank you, Raj. All right. There is a question from Sridhar. When you gave example of movies, you said we know about the user. Can you come on that again? Okay. All right, let me just explain what I meant. Here, when we are saying customers who bought this also bought, here we don't know about you who is visiting this website. Okay, therefore, since we don't know about you, we don't have no clue about your history, therefore, we are giving you such suggestions, such generic suggestions that people who bought this also bought this. Okay, we are not saying you may also like this. Okay, these are the recommendations where it's not user based, but here it says clearly, congratulations, movies we think you will love. Okay, here the u is in bold. Okay, it has gathered the statistics, it has asked you hundreds of movie ratings, and based on that it has given a suggestion that these are the movies you will love. It's not saying these are the movies people who bought the movie, this movie is also liking this movie. This is user to user recommendation. This is user to user recommendation. This is user product recommendation. All right, do I make sense now, Sridhar? All right. There is a question from Darshan. We will take up this question as he says. No worries. Okay. And yeah, we'll take up this question and we talk about it in details. Any other questions at this point for me? Yes. So Sridhar's point is it means recommendation was made based on information gathered. That's correct. Okay. All right. Let's take a break for 10 minutes. We'll be back by say 10:11 p.m. IST. All right. Let's take a break for 10 minutes. All right. All right. Um, okay, so should we start? Is everybody back? Great. Let's start then. All right. There are great questions. There's a question from Raj. Let me just copy paste it here so that everybody can read it. Okay. And let me put it again. All right. The question is, nowadays, whenever we search for something in Google or about any product on e-commerce online, after all, we also get information about product on some other website like Facebook when visiting. Is there any way related to big data analysis? If yes, hi. This is called, okay, this is called, what do you call? This is called something called cookie sharing. Okay. So, and also it's called remarketing. Okay. So this is a feature provided by all major ad network provider. Okay. So the idea is that the cookie or the information gathered by about you by say Google or or any other website, say you visited no big data once, and then so this information is automatically being tracked by Google, and then they will start showing it elsewhere wherever there is a Google ad. So this is called remarketing. All right. So definitely the big data is involved because there are too many users for who this information is being gathered. But if there are only few users, it's not that difficult to actually do it. It's called remarketing and it's a part of cookie sharing. Okay. So if you know a little bit about how do browsers know and how do um, the, basically it's you are identified by a number and which is being reshared. Okay. So yes, let me just make save the notes. Okay. All right. So Vinod's question is that is Hadoop only way for solving big data problem? I feel I feel there is a problem of plenty in terms of knowledge and tools available with Hadoop and how to minimize this problem. Let me take it up after like few minutes. I think you will get answer to the first part of the problem and then we will talk about it again. All right. So there are I think three questions which I have not answered. Great. Great question. Now, all right. So there are quite a few common myths about big data. All right, let's just clear those myths. One is big data always means data above or in range of terabyte, which is not really the case. That big data could become big data because of other two properties as well, velocity and variety. Okay, velocity and complexity. So, and second is always about social media and doesn't apply to me. No. It's not about social media. It just so happens that social media's data is easily available to everybody, and therefore it becomes a good recipe to quickly gather insights into behavior of people. Okay, but almost everywhere where data is expanding, where data is not being able to be handled by the relational databases or file systems, it would apply to you. Third is, will it replace enterprise data warehousing? So, yes, it would replace partly, but data warehousing serves multiple purposes. Okay. So, part of the enterprise data warehouse would actually be solved using the big data, while most of the data would still continue to remain the way it was, because most of the relational data is very difficult to be handled by any of the big data tools. All right. Next question is, it is just a it's a next common myth is, it is just a buzzword. There are no practical application. It's obviously not true, because this is the only buzzword which actually has some context to it. There's a lot of useful full there's a huge ecosystem of product and huge ecosystem of developers and data scientists and the users. Okay, so it's not really just a buzzword, but there are really good practical applications. I have been into the industry for quite some time, and I have seen a great use cases in case of Amazon's, in case of InMobi, and even in case of a financial firm called DE Shaw. Okay, it is a new concept. No, it has been there, as I just explained, that in DE Shaw we were handling petabytes of data quite a long time ago. Okay, since 2002 we were handling thousands of terabyte of data, and that was something very surprising to lots of people, that uh, that petabyte data was there being handled very well. When we had hard disks of 16 gigabyte or 8 gigabyte, that time the kind of storage we had built was in petabytes. So that was something which was, it is not a new concept, it has been there for quite some time. Will be the future? No, it is the present. Is expensive? No. Most of the big data solutions are built to avoid very high-end custom solutions which are very costly. If you if you think about the cost of a supercomputer, or if you think about the high-end blade servers, they are, if you find out about the prices of these kind of devices, they are really high. Same devices, if they are connected to the network, if you buy, let's say there is a 10 lakh, in 50 lakhs you are getting a computer, a supercomputer. In 50 lakh you can actually buy 100 decent nodes, and you can connect those 100 decent node and make a data center out of it. Okay, so therefore, most of the big data solutions are not expensive. They are less costly. The only thing that's expensive as of today is the engineers, and that is because of demand and supply gap. All right. Now, next myth which I see all around is, it is only for big data scientist, or it's a magic. Not really. It's for almost everyone. Though there are few parts where you need data scientists' help in optimizing algorithms, finding better algorithms, but the good news is most of the algorithms are commoditized, meaning most of the algorithms are available for free, open source world. Most of the almost best algorithms which are needed for any job are freely available. Okay, free as in open source. Therefore, it's no longer magic, and it's no longer only for few data scientists. It's for everyone. For others who are not really well aware about the algorithms, they can just use off the shelf products to solve their problem. Now, ninth question is something which I keep hearing all the time, although it is not related to it anymore. We have enough hardware. We don't need anymore. Okay. So basically, in case of big data, almost every big data solution focuses on building a distributed computing environment rather buying really high-end server. So it's neither expensive nor you have to buy an additional hardware. You can start using whatever hardware we have. Okay. Now, next 10th point is we will build it when we need it. Okay, when we will build it when we need it. This is another syndrome, this another problem which I see with lots of people. And somebody was asking what are the main challenges. These are the main challenges for big data adoption, because when you meet people who are not aware about big data will give these excuses. Okay, but let's say if you take a case of this is a common syndrome, people come up with an excuse that we will build it when we need it. But the truth is, the day you realize that you need you need to give the analytics of your end user, you will have no data available for you. Okay, at that point of time you will feel that you will regret that we should have stored all the information about the users. Okay, therefore you have to plan now in case in future you're building something which is useful. Okay, so you cannot build it on demand, you have to have data to be handled, otherwise there is no point of having a big data solution. All right. Big data is all about Hadoop. No, big data is not about Hadoop. There are many solutions, there are many stacks which are available. For example, take this case. Okay, there are many big data solutions. Hadoop, along with Spark, is one. Cassandra in itself is a big data solution. MongoDB in itself is a big data solution. And in case you are open to moving your data to Google Compute Engine, then that is also a big data solution. All right. Now that is about myths. Now the salary trends. So this is a snapshot. I took it some time ago from Indeed.com, and this link. There you can see easily that Hadoop salary are the highest. Hadoop salary are the highest. You can see that this graph is also true as of today. The average Oracle salary is 97,000 USD, while Hadoop salary is 112. Java MongoDB is 102 and JavaScript is 94. Data scientist is actually lesser. Can you believe this? All right. So that is the trend in the industry. You can also see the the graph is like this. Okay. And this is for the same dates. Let me change the duration. Can we change the duration in this? This is from Indeed.com. Okay. All right. So you can clearly see that the salary trends are really great even as of today. And I don't know how to increase the search, add comparison, show job titles. Anyway, we can have a look at it again, right? So you can see that there is a need in the industry. It's not that it's a empty bubble. Okay, it's not an empty bubble because lots of companies have been using Hadoop and big data and other big data solutions for probably 4 years now. Okay, lots of companies, the mainstream companies. Outliers were there like Google's and other people like Deisha has been dealing with big data since 2000s. Okay, so there was a question which I did not answer earlier here. So one question was, can you please list out any challenges for Hadoop adoption across all companies, ranging from startups to mid-level? One is one is lack of understanding and vision. Okay, lack of understanding that I mean, what is big data and how can it help? Okay, etc. Vision is like what all places they could use. Okay, so that is more. These are the most important thing, and there is some honest cases where they, I mean, not having big enough data. These are the honest cases. For some projects, you don't generally have too much of data, and you do not see that the data is going to grow really higher. All right. These are the two. Basically, lack of education is what I see as the problem. All right. So that is answered. All right. So there is few more questions about the career. So let me just take a few this particular question as of now. So question is where and how to showcase practical work, dummy projects, internship boot camps, competitions, etc. Okay, there are few advice to you here. One is if you are doing a training like, for example, at No Big Data, so any project you do with us, you can display it on your LinkedIn profile. Okay. So one is attending a course, attending a course. So I'm answering your project's problem. Okay. Let me just break it down. Let me just break down the projects. So what can you do about building a profile? One is attending a course and displaying the certificate given by us on your LinkedIn profile. Okay. As of today, the LinkedIn profile are great for displaying. Third is you can display things on GitHub. You can do two things: create, or you can say contribute to some open source product. All right. And fourth is for boot camps or internships, not internship, competitions. Okay, competitions you can try kaggle.com. Okay, it's actually decent, very decent. And with respect to internship, there are many companies, okay, many companies who are offering internships, including the main important companies like Cubole or Hortonworks, Cloudera. They do offer internships, as well as many companies like Dell. I know that Dell had lots of openings for interns in big data, as well as other companies. So, and everybody knows that they will not be able to get experienced people into big data domain. So they are generally open to the people who have attended some course or attended some training. Okay. So there are many companies offering internship. So have a look at those internship websites. You will get lot many answers. Now, question from Vinod is how to find test data for trying POC in Hadoop or machine learning. There is a lots and lots of data available. So if you go to UC Berkeley, for example, UC, what was that? California, or let's say big data sets. There are many data sets actually available in public domain. Okay, so you can have a look at this. Okay, here is KD Nuggets. Okay, so there are actually, this is a big data set. Like for example, there's a common crawl corpus, and there are many more examples. So you can see that there are these data repositories available to you on which you can do test. All right. Now, question from somebody, I forgot the name. Typical learning path about Hadoop admin. The way you can only learn Hadoop admin is by understanding first, understanding Hadoop, and then trying out the provisioning tools, okay, such as Ambari or Cloudera Manager. But I would prefer Ambari, and that is one thing. And trying it out. Okay, you cannot trying it out on multiple nodes. There are many documentation available. And with respect to developer, by understanding Hadoop uh, details and trying to solve couple of problems. Okay, that's the only way to learn the developer path. Or you can try with books like Definitive Guide. Those are good. Or my self promotion, you can attend my course. All right. And with respect to data scientist, the path is actually complex, and you can start with the what was that scikit-learn. Okay, scikit-learn is a good starting point. All right, I hope I've answered your question. Now there is a question from, all right, there's a question from Sridhar. Who all can get into big data? Okay, now very good question. I think this question almost all of you would be having. So in big data, there are many kind of openings and many kind of positions. Okay, one of the common one is analyst. Okay, analyst, someone who can query the data lying on big data platform. Okay, using pig, hive, etc. That is analyst. Okay, And next is the developer who can build application and can programmatically control or query the various components. All right. Then there is a data scientist. Okay. So data scientist is somebody understands who understands the various machine learning algorithms and have, okay, other than the developer and data analyst both need to know a bit of programming. Okay, knows programming and knows maths well. Okay, and programming. That's a data scientist. All right. So basically, you can fit into any of this domain, and you will be able to handle it. Okay. So analyst is somebody who knows, who understands, databases basics and can query using SQL. All right. So that is my answer. I hope I have been able to answer, Sridhar. All right. Great. Good question. Now there is another question from Vinod. All right. The question is, if I have to create a dev environment for 5-member team at my office, is it good to have single node installation in a server or procure 3 server box to form 3-node cluster? So my advice would be procure procure 3 nodes. Okay? Because single node cluster doesn't make any sense. The only difference between big data and normal computing is distributed computing. Okay, so it doesn't make sense to have only single computer. The reason, I'll tell you, this is a very important question. So the reason why we started providing cloud labs as a general platform having many nodes, so that individuals understand that okay, this is how the distributed computing is done. Otherwise, when people were using VM for running their all simulations and just downloading VM and trying to run it, the problem the everybody had was, what is the point of this virtual machine? I can run the same Java program in a faster manner without this machine. Why am I running this Java program inside Hadoop, inside this virtual machine? Okay. The most of the people did not understand that the objective of the Hadoop or objective of any big data solution is to utilize many nodes together and get your work done. Okay, and unless until you actually try to do it, you will not realize the difference. Okay, so my strong advice is procure minimum 3 nodes. Okay, procure minimum 3 nodes. That will be my advice to you. Okay, I mean, that's the biggest benefit of the cloud labs which we have launched, that people get to see that okay, when I launch my MapReduce program or when I launch my program on Hadoop, is being executed parallelly by so many machines, and there is a huge difference in the computing time. Okay, does it make sense, Vinod? Okay, so all right, I'll just give you very rough. The question from Vinod is any specific recommendation for minimum storage. So have Node 1 around 8 gigabyte RAM. Okay, this is Node 1, and let's say Node 2 to Node 3, you just take 4 GB. This is like minimum. All right, great. So that was good set of question from Vinod. Now moving on. Now let's start with our discussion on Hadoop. So when we discussed about big data solution, probably out of all the solutions available as of today, Hadoop is the most complete solution. Okay, Hadoop is one of the big data solutions. It was built after Google's paper on various technology stack. Okay, so Google published three papers: GFS, which is Google File System, Google MapReduce, which is Compute Engine, and Google Big Table. So based on these three papers, some these Dog Cutting and Mike Caffarella, they wrote Hadoop. Okay, following these research papers, so they wrote Hadoop. Basically, they were trying to create a search engine called Nudge in their hobby time, and they were stuck. They were stuck realizing that searching the internet or crawling the internet will require a lot of efforts. Okay, it would not. We will. They will. They were not able to store such a huge data using their traditional tools. Okay, for many reasons. So they could not store huge data using their existing tools at the same time, so they were stuck kind of. And at the same time, Google came around and published these three papers: Sanjay Gehmabat and Jeff Dean, and there were one more researcher who published these three papers. And based on these three papers, the whole Hadoop was created. It was named after the toy elephant, a toy elephant with which Mike Dog Cutting's kid was playing, and, and it was open sourced, and that too Apache license. So probably one single thing that has been the most important for for this Hadoop is this license, because this is the license which is probably the most liberal one. If you want to package Apache with your product, Apache is completely okay. If you want to anything which is Apache licensed is probably very liberal. You want to use it for research, you want to use it for production, you want to use it for printing money, it's up to you. How whatever you want to do with it. Okay? Apache does not restrict you from any kind of usage. Okay, as long as you ship the licenses, as long as you don't start selling Apache product without any additions, Apache would not mind. So that's the kind of a license Apache community provides you. Okay, and Hadoop has the same characteristics. So when people did not have a fear of using Hadoop, it did not have any hidden conditions that in case you are using our product, you have to give us, you have to send us the contributions and so on. Since it does not have those restrictions, it was adopted very quickly. And anything which is data intensive, anything which locks in the data, if it's not open source, it will never be adopted. It will never be adopted. As I was running my TBITS Global earlier, since before 2000, from 2006 to 2011. Okay, so when I was running that company, what I realized was that that people were not adopting my product because we were closed source. So at that time, whenever we used to discuss about the license, we used to tell them that we will give you the source code if you are going ahead with it. So it was very important decision, because if tomorrow a company adopts your product and you are no longer in business, the company's data is logged into the product. And that is why Apache license or open source products work very well. And that is why any database launched, any NoSQL database launched today will have open source license. There are 200 plus databases, NoSQL databases, which are open source as of today. Okay, so uh, and out of most of the licenses, Apache is probably the most liberal one, and it's quite popular, powerful, and supported. Earlier, when people used to talk about open source product, it used to convey that it will not be well supported. Somebody had just taken some product and put it on in the open because he was not using it. Okay, but that's not anymore. It's a proper viable business model. Running a open source product is proper, viable, and business model is very powerful business model, because you do not have any marketing expenses. Marketing expenses are being avoided because people start trying your product, which is in open source, and start reviewing it, and then you don't need a marketing pitch. And so basically, open source has been the biggest deal in building new databases. Okay, and since the data gets logged in, there is why not many companies could get into that database domain. After after those very few handful of companies such as Oracle, Microsoft SQL, and Postgres and MySQL. MySQL was successful because it was open source. Otherwise, it would have been very difficult. All right. It is for reliable, scalable, and distributed computing, and it's a framework to handle big data. Now, the point number H is probably you should pay most attention to any component which is also Hadoop is now a umbrella term. Okay, it's not a single product. It started with three products: file system, compute engine, and database. But now it is more than 11 components which lie under the umbrella of Hadoop. And all of these 11 components have these common characteristics. They are reliable as in case one machine fails, the other machine will start working. Second, it's scalable as in today you need three machines, tomorrow you need five machines. The software should automatically expand to fill the need, or the data should automatically flow from the existing node to another. Next is distributed computing. Whenever we want to compute something, it should be able to get it done using multiple computers. Second, it should rely on the data locality. So these are the common characteristics which are there for every Hadoop products, be it HDFS, be it MapReduce, be it Uzi. We'll talk about all these products. Okay, all of them have to do with distributed computing, scalable, and they have to be reliable. All right, before I move on to the next screen, let me answer a few questions. Okay, Indrajit's question is there any relation between blockchains and big data? All right, let me answer it this way. So blockchains are actually huge. blockchains are actually very huge in nature. Okay, because every transaction creates a new node in the blockchain, and to churn such kind of data you will have to have distributed computing tomorrow, or you will require lot of computing capability to actually do something. To churn big data chain, sorry, blockchain, you will require multitude of computers. There, that is the only common thread between big data and the Bitcoin. All right, makes sense to you? All right, very good question, Indrajit. All right, yes, Raj, you have raised the hand. Oh, okay. So, do you have any questions for me, or did I miss anybody's question in past? I think we have covered everything. Okay, there was this question which I skipped. Let me answer this. The question was, does it make sense to get into big data if someone does not have any software development experience? Okay, so in this case, I would say, as I was explaining earlier, that if you are from analytics background, anal- analytics background, then you know if you want to go get into analytics, you must have some kind of a little bit exposure about databases. If you have some database exposure, then you can go for analytics. Okay, for that you don't generally require too much of programming experience. Okay, but it is very important to understand what does it mean by big data and how does it impact. All right, good, good. Let's move ahead. I hope I have not missed anybody's question. All right, I think I've answered all the questions. So, does it mean to have a knowledge of managing? Not really. Not really. If you can write, if you can write SQL queries, if you have understanding, if you have understanding of SQL querying, then you're good to go. Okay, that's good enough. Okay. How is it different from ETL? So ETL is just one part. So you have, what does ETL do? ETL stands for extract, transform, and load? That's a question from Raj. Good question. Uh, and load. So it's a common term when you have some raw data, some unstructured data. You want to convert it into some meaningful data. So then you go through ETL. Okay. While in case of big data analysis, your big data analysis includes both. Okay, or you can say structured data. So after structured data, you have analytics, which gives you insights, right? You have raw data that gets converted into some structured data with a structure. And once you have this structured data, clean data, you can do the analytics. Okay. But in case of big data, what do you say? Big data analytics or big data analysis. Okay. You have everything. Okay. You have you start with raw data and you end with insights. Okay. So that is the difference. So big data analytics or big data analysis includes everything. It includes because even the ETL is a very difficult proposition when the data has grown into terabytes. So even for ETL, you would require new set of tools. Okay, was I able to answer, Raj? So there's a question from Sridhar. Question is, what kind of roles are available in the market for big data? For example, I become analyst, then what will the next level of the role in the career? Okay, so I mean there are various levels in analytics because analytics is a very huge domain, and so in analytics itself there is a full hierarchy of roles, and okay, so basically, and this hierarchy will be up to the organization. Okay. All right. So the what kind of roles are available for big data? Roles, somebody has done the job earlier. Yeah. So one was into analytics where you are given some data and you are supposed to use the tools like SQL and pig to give the results. Okay, that is the analytics part, the role of a data analyst, which can convert the data from one form to another. Second comes the developer who builds the application, builds the complete solution end to end. The third is and big data architect is a level up from developer, and and then another role called data scientist in which we analyze, in which a data scientist figures out new ways of giving insights on data. All right, was I able to answer, Sridhar? For the second part of your question, it all depends on organization. Okay, whether they have senior analyst, do they call something else, it is up to the organizations. All right. All right, so that was a little bit about Hadoop. So I will go into the details of, okay, somebody has raised a hand. So there is a question from, it's not displaying name. So his question is, I am a final year student, so will there be a role for me in big data? I have no experience behind it. Okay, so before getting into big data, I have few little advice for you. Have a good handle over SQL. Understand SQL. Okay, no matter how many times people call NoSQL, you must get understand the SQL. Okay. Second is know a little bit about programming. Okay, little bit about programming at least. You should know how does a program looks like, because that will be used everywhere. And a little bit about Unix. Okay, then you can get into the Hadoop development or Hadoop developer, and even if you are joining a fresher, you will be able to do a very good job. Okay, and people are actually those people who know how to measure the capability. They generally don't look for the certification or any kind of other symbolic achievements. Okay, so even without experience, you can get into big data domain if you have this experience along with a knowledge about big data. Okay, a knowledge about big data is important because that shows that you have put efforts to learn it and apply it. Okay, make sense to you? That was Sekhar's question. All right, thank you, Sekhar. Now moving ahead, there was okay. There is one more question related to career. Question is, to become familiar with Oracle, we can install Oracle. For MySQL, we can install the same. For learning and becoming familiar, to become little familiar with big data analytics, what should I install on my computer? What are the resources before joining the course? Okay, so what we do is generally we provide you a cloud labs. I'll show you how does it look like. So you don't need to install. Okay, all you need to open is in browser. Everything is available from the browser itself. You have a terminal inside browser and everything is. So for joining the course you don't need to install, but if you are not joining the course, you can go ahead even for only the cloud labs that will be launching soon. Okay, second is, if you do not want to go for the course, or down you're not interested in cloud labs, what you can do is you can download the virtual machine provided by Hortonworks. Okay, the only problem with this virtual machine is it will take a lot of RAM. You will need to give it 4 GB of RAM. All right, that means you need to have a 8 GB of RAM in your computer. All right, was I able to answer, Raz? All right, let's move ahead. All right, now the main important part. Okay, now the most important part about today's session. Let's try to understand the component. Keep asking the questions, so I might stop in between to answer your questions. Okay, so all right. So as I told you that Hadoop is a umbrella term. Hadoop is an umbrella project containing so many small projects, and out of that, the most important product or the most important component is Hadoop distributed file system. It's a file system which runs on 10 computers or 15 computers parallelly. and without you knowing about it. Okay, let me show you how does it look like. Let me show you how does it look like. Now you see this, under here there is this nice file system, okay, in which there are folders and files. Now you will be amazed to know that this file system is built upon many computers. So it might be that some part of this folder is on one computer, some part of this folder is on another, and so on. Okay, so basically HDFS or Hadoop Distributed File System is a file system that runs on multiple computers at the same time. Under the hood, the files are stored on multiple computers, while on the surface, it looks like a neat, nice file system. Okay, it has got folders, it has got files, and files could be of any size. All right, it has got a backup, as in case one computer dies, if it's running on 5 computers, if one computer dies, it is able to recover the data because it has multiple copies of the same data. It breaks down the files into small chunks and distributes it across the cluster, and whenever one machine dies, suddenly the data is replicated automatically. Therefore, it has got this great strength of managing, it has got the great strength of recovering from the failures. So those are the few properties about HDFS. We will dive into detail in the second session. Okay, there are many uh, details about HDFS which you can utilize, you can understand and utilize in your strategy and in the solution. All right. Niles's question is, will we have an access to Cloud Labs after completion of the course? So with course, you get 50 days of Cloud Labs free. If you want further, you can have it at an very small amount of additional price. Okay. But we honestly promote that our students should learn rather than worrying about buying. Okay. All right, so the main component is HDFS. It is the ground on which the whole Hadoop stands. Everybody uses HDFS. It's the only file system having such a massive scale of such a massive scale to expand. You can keep on adding more and more computers without having to redistribute, without having you to take care of, okay, now I have got 10 hard disks, I have to move this folder into this, that folder. No, you don't have to worry about any of this. Hadoop takes care of it automatically for you. All right, that was HDFS. Okay, HDFS is file system, as in it has got folders and files. Everybody stores data in HDFS at the end of day. Okay, and it is very scalable, as in if you have more machines, you can add more machines. If you have need machines, you can take out the machine one at a time. And also, if you have big file, still it can manage. Next is, on top of HDFS is everything standing in Hadoop. The immediate one is Yarn, which is called the compute engine, or you can say resource locator, as in yet another resource negotiator. That is Yarn. Yarn is an architecture, as in using Yarn, various components talk to Yarn and get their work done using multiple computers. Okay, let's say you want to get something executed across 5 nodes. Okay, so you will talk to Yan programmatically and tell Yan, here is my program, please execute it. So Yan will get that work done. So Yan is like an operating system for Hadoop. Okay, the way operating system negotiates the resources. Many programs talk to operating system, and operating system negotiates the resources with various tools. Similarly, Yarn is a kind of an operating system for getting your work done on multiple computers. Now, on top of Yarn is the paradigms like MapReduce and paradigms like products tools like Spark exist. So MapReduce is a way of structuring your program. So when you want to get something done in in a network in using hundreds of computers, you have to write a program which can distribute itself. A program whose logic can be divided such that there is no interdependency. And to do that, people generally write the program in terms of map and reduce. The way when you churn data, you write your program in terms of SQL queries. In the similar way, when you have to churn data, you using MapReduce, you write maps and reduces. Map is a logic which gets executed on many computers, and whatever is the result gets sorted and passes through the reduce functions. We will go into more and more details about MapReduce. We will cover MapReduce in very high details with really difficult problems as well as very simple problems. Around 8 problems we will solve using MapReduce. Why? Because MapReduce is a very important distributed computing phenomena because of which lots of things could get done using network. So recommendation engine internally uses MapReduce to get work done. Okay, we'll go into the so MapReduce is a way to express your logic such that it can be executed parallelly on hundreds of computers using yarn. Okay, so that is MapReduce. Next is HBase. All right, so when you have to write humongous structured data, you know what does it mean by humongous structured data? Millions of columns by billions of rows, millions of columns by billions of rows. If you have to write or read such kind of data, and that too structured, then HBase is probably the only solution. Okay, when you have huge structured or semi-structured data and you want to edit such data at a very fast speed, then probably HBase, the Hadoop database, is the only solution. Okay, I mean there are MongoDB, Cassandra, and other NoSQLs, but to handle such kind of data, this HBase is the NoSQL database provided by Hadoop. Okay, what is a NoSQL database? A database which is not really a typical relational database or RDBMS database. Instead, it's a database that runs on multiple computers at the same time, meaning when you create a table in such database, the table is distributed on multiple computers. When you create a table in NoSQL database, these NoSQL databases call table with different name. For example, MongoDB calls a table. MongoDB calls a table collection. Okay, and HBase calls table a table. Cassandra uh, calls table as yeah, table only. So in case of NoSQL, the table get divided on multiple cluster. Some rows here, some rows there, some in on other computer, and so on. Out of some rows, some columns are here, some columns are there. And this HBase kind of database or NoSQL database are able to scale up. More users, no worries. You add more machines, okay, and it will automatically distribute the data and solve the problem. Next is, as I was explaining to you the map reduce, sometimes not everybody is a programmer, and people who have some SQL experience would like to get their work done. In those cases, you can express your logic in terms of SQL. That will get converted into MapReduce. That is Hive. Using Hive, you can start writing SQL queries, and those using those SQL queries, you can start churning data. But please notice the difference between Hive and HBase. Hive is not a database. It is just an engine which converts your queries into MapReduce. It's just an engine which makes the life of people who do not know programming easier by providing them a converter from SQL to MapReduce programs internally. Okay. Also, Hive does not provide you the ability to edit the records. Okay. So now you understand the difference between Hive and HBase. The next is Pig Latin. Pig Latin is SQL kind of a language designed from bottom up for handling big data, for querying big data, not writing to big data or modifying big data, but querying the big data. If you have to query the big data, you will find it very comforting to use Pig. Okay. Next is Mahat. Mahat is a collection of algorithms, or you can say it's a library of algorithms for various kinds of machine learning. As in, you can train it and it will automatically start working for you. The recommendation, for example, is all available off the shelf in Mahat. All you have to do is call Mahat's that particular library. That's it. And you have it there. So Mahat is like a magician. On top of it, most of the magic works like finding the recommendation, finding the anomalies, figuring out the various kinds of learning behaviors. So all of that could be done using Mahat. Now, for pushing the data into HDFS, you would require some tools. Okay, so if you have got unstructured data, you use Flume. If you are trying to push structured data in huge numbers, then Scoop will be your solution. Also, if you are, say, trying to build recommendation based on some data, once recommendations are done, you can pull those recommendations from Hadoop into a database, okay, using Scoop. So these are the things being done by various components. Okay. All right. Now there is a question from Nilesh. Not Nilesh, Vinod actually. All right. The question is, can HBase be database for machine learning output, modeling platform and visualization data? All right. So I will try to explain it in parts. First, let me try to answer this. Can HBase be a database for machine learning output? So my answer is you don't need to. Okay, let me explain again. So, so Vinod's question is, say we have designed a very great algorithm which is doing recommendations, taking some data and preparing that this user may buy this user may buy that. Let's say this result, if we have to store this result, where would we do it? Can we do it in HBase or should we do it in HBase? My answer is no. Don't do it in HBase, because whenever your machine learning program or any program that matter, for that matter, which gives the insights, the result is one time. Next time you will have to discard the whole result and start afresh. Okay, because in case of recommendation or any predictive analytics, the the result will immediately change even on a single variable. All right, so it doesn't make sense to put the data in HBase because it's one time output. It will be useless when you run the program again. You run the recommendation again, the result will be different. Therefore, you don't need to push it to HBase. You put the data into HBase, which you have to very frequently edit. Okay? And about modeling platform and visualization data, you can feed the data from HBase or maybe HDFS, or maybe, so generally you just directly put such kind of machine learning output into HDFS like a big file. Okay? Now, modeling platform and visualization data. So, so your question probably is, can the modeling platform output the data to HBase? Yes, for modeling platform, if you suspect that your data will be modified continuously, then you can go ahead with putting it into HBase. But for visualization data, you generally don't keep it in HBase, because when you generate visualization insights, the outcome of visualization insights is very small. Okay, because if you try to visualize a big data containing 10 billion points, it wouldn't make much sense to the human eye. Therefore, it makes sense to convert big data to small data and then visualize the small data. Okay, so you can actually, for visualization modeling as well, you can very well use either HBase or any of HDFS. You can use HDFS as well. Okay, so Vinod's question is how to achieve a unified schema of multiple data source aggregated at HDFS after ingesting. Okay, so you can basically clean up the data and put it in a single store. It should not be a problem. Okay, you can put it in HBase, so you can put it in any of this structure. If that is your objective, if your objective is to build a unified schema, then probably you can go with HBase. Now, Sridhar's question is, does it mean all these components are installed? These are all installed by default. Okay, these are all. So only the core part is the HBase and HDFS. Rest are like softwares. Okay, these are like separate software actually. Thank you, Sridhar, for clarifying this. Where else can we store machine learning output? You could use actually hcatalog. Good that you have mentioned it, or HDFS, or you could even just put it in a Hive. That's it. All right. So that was Vinod's question. All right. Very good set of questions. All right. So I'm almost on towards the end. Okay. So a quick, I've already talked about what do we offer. So So we have a real life experience Cloud Labs as I was displaying to you. So this is, for example, this is our file browser. You can run pig here from here. And this is a tool called Hue, which we are using. You can use a workflow creation tool from here, or we will also show you how to run these programs from the command line. Okay, if you if you let's say there are some tool which want the command line interaction, you can also use this browser based console. Okay, let's say you want to run pig, you can run pig from here. Okay, so all of this is installed, pre-installed for all of our students, so they don't have to worry or they don't have to roam around with the information. Okay, so all of this has been done to facilitate the learning so that the focus is on solving problem and learning. So Vinod's question is that is it true that it's time consuming to set up local? It's a little bit time consuming, okay, a little bit time consuming, but not that too much. Okay, I give you a tip that use a tool like Ambari, okay, and you will be able to install the cluster very quickly. I have installed cluster multiple times and I was fairly comfortable. So you can see we use a tool called Ambari to monitor our uh, our full network. Okay, so you can see that this is the status of my cloud labs. Okay, and these are the various tools installed. All right, good. So upcoming courses, th- there are some courses upcoming. You can enroll if you really like to. All right, and these are the upcoming courses. If you go to knowbigdata.com, you will be able to see. So another question from Vinod is, okay, any particular distributor which is easy to start with, like Cloudera or Hortonworks? I prefer Hortonworks. Okay, all right. I have tried both. I prefer Hortonworks so far because it was easy to install and quick to install using Ambari. Okay. So these are the course starting. One is starting on 10th of October in evening. Other is starting in morning from 17th of October. All right. So you can, yeah, great. All right. So that was pretty much about our course. And so this slide is generally for students where they can finish the quiz and everything which is built on top of today's session. And we provide a kind of a lab in which learning management system in which all the video recordings of the sessions will be available, and all the notes, projects, data, everything is inside our learning management system. All right, so for further reading, these are the links, you can have a look. And yeah, all right, so next is on 10th of October, 10th of October from 8:30 p.m. and other is 17th of October from 7 a.m. Is that it? Yeah, that's correct. So there's a question from Raz. Question is, are these online courses? These are online courses just like today's. Okay. So we will take you through each and every topic in detail, just like today. All right. Will we get details that what all is covered? Yes. So in summary, I'll just tell you. So other than the things discussed on this slide, Flume, Scoop, Uzi. Uzi is the one I forgot to mention. Uzi is the one in which you create workflow, and command line Java or Python you can use for interacting with any of these tools. So all of this plus all of this plus something called Zookeeper and Spark, we will go into detail. Okay, all of these are covered in these 11 sessions. Okay, you can have a look at the detailed curriculum here about the course. All right, see there? Yes. So yes, $349 is the total fees for all over the course. So Vinod's question is, will it be taught by you or others? Most likely, I'll be taking this class. So Vinod's question is, can we attend? So no. Even my neighbor had to attend my classes, so they had to attend it online. All right. All right. All right. Raj's question is, when is the offer and discount come? So you can actually just, if you come online or just drop us email at reach us at no big data. Okay. So we can discuss it further. All right. Because there's somebody else who takes care of this. All right. With respect to offers and all of this, I generally take care of the classes. All right. So you can basically write to us, and this is our website. You can have a look at it. All right. Great. Thank you very much for today's. That's pretty much from my side. If you have any question, you basically, if you any technical question or anything, just raise it on the forum. Okay. We will answer it there. Okay. You can go on to the forum and ask the questions. All right. All right, stay connected. Even if you are not signing up, it's completely okay. We very well understand that this course is not suitable for all the candidates, but the first session is we try to make it very generic so that people who are interested in knowing the technology stack, whether they are from sales, whether they are from finance background, whether they are from real estate background, they should get an understanding of what exactly is Hadoop and what is exactly is big data, so that they can take a call. All right, great. Thank you, Raz. Thank you, Madhumita. Thank you, Vinod. So Sridhar's question is, will we get this presentation on the trainings attended today? Yes, you will get the video and these slides in the email. Okay, we'll send it by tomorrow morning. Thank you, Nilesh. I'm happy that you found it great. All right. Thank you. Thank you, Indrajit. I'm happy that you liked, you found it great. All right. Thank you, Sridhar. Thank you for the compliments. All right. I take it as a compliment. All right. Thank you, Madhusudan. All right. I'm happy, Sanabas, that you found the session as great a starter, and I hope to, keep doing well in this area. Now there's a question from Raz. Will we get career assistance? So yes. So we will be. I'll be very honest with you. Will not be providing you, kind of a job guarantee, but whatever, whenever people have the requirement of big data experts, they generally send an email to us, and then we send that vacancy to all our candidates. All right. All right. Thank you, Ram. Vinod's question is, if we have to look for some intern, just send a mail to reach us. Okay. Okay. Just send a mail to reach us. We will send it to. There are many candidates who work with us, all our students. We'll just circulate your mail to all the candidates. All right, Vinod. Great. All right. Thank you very much, and have a great day ahead. Bye bye. Good night, Nilesh. Feel free to stay connected. If you have any question, just drop us an email. If you have a question related to the course or anything, just drop us an email at reachus at no big data. All right. Bye bye. Have a good day.